So we are given these expressions and we're asked to calculate the value of each of them, given that x is 2, y is -3, and z is 5. So let's start with the first one, 5x squared z. And now we want to make our substitution. Well, let's write this out. This is saying 5 multiplied by the square of x multiplied by z. You could go ahead and substitute it like this, or if you want to expand it further, you could say 5 times x times z, because x squared is actually x times x. So we can say 5 multiplied by, now we're going to replace the x with 2, since x is equal to 2, multiplied by x again, and we know again x is actually 2 no matter where we see it in the expression. X has the same value. Then we're going to multiply by the value of z. We're told that z is equal to 5. So replace z with 5. And then we simplify our expression. So we know that 5 times 2 is 10. 10 twos, 20. 20 times 5 is 100. And that is our first solution. Now let's look at question B. In question B, we have the expression 3xy squared plus another term 2x cubed z. And so we can simplify this first off by first substituting the variables with numerals. So we're going to replace x, but before we do that, we can just expand first off. So we can say 3 times x times y squared, and y squared can be written as y times y. So instead of writing y squared, we can simply write y times y. Plus 2 multiplied by x times x times x multiplied by z. And then we're going to do our replacement. X is 2 multiplied by the value of y, and y is -3. Put -3 here. You're also going to replace this y with -3. So that's going to be -3 times -3, which is really y times y, or y squared, plus 2 multiplied by the x value, and x cubed is x times x times x. So it's really what? 2 times 2 times 2. So let's put that 2 times 2 times 2. Of course, we want to enter the multiplication symbol there. Multiplied by the value of z being 5. Just using a different color to highlight the substitution that we're making. Now let's simplify the first expression there as one number. 3 2's, that's 6. In fact, let us do it 2 at a time. So 3 2's 6 times, but what this times? -3 times -3. Now we know negative times negative is positive. 3 3 is 9. Okay, so that's really 6 multiplied by 9. Plus, we're going to utilize this plus in the last step. 2 2's, that's 4. 4 2's, that's 8. So in other words, let's just write 8 here. And then we say 2 times 5 is 10. We're just breaking it up for now. So this is going to give us 8. 2 times 2 times 2, that's 8. And then we're going to say times 2 5 is 10. I mean, you could have just multiplied everything one time. That would be fine as well. 6 times 9, that's 54. And 8 times 10, that's 80. Now 54 plus 80, that's 134. That's our solution. Let's now move to part C. Now, part C, we have the expression 9x squared z minus the term 4xy to the third power. So we're going to expand first before we make our substitution. So 9 times x, because x times x is x squared, multiplied by z, minus 4 times our x value times y times y times y. Okay, remember these are variables. They represent a number or any number. But in this case, the specific number for x is 2. So we can say 9 times the x value being 2, that's given to us. So 9 times 2 times 2 times z. What's the z value? That's 5. And so we're going to say minus 4 times the x value that we have is 2. So it's 4 times 2 times the y value, which is negative 3, times again negative 3 times negative 3 again. So y, as we're seeing here, is negative 3. So we replace y here, here, and here in 3 parts with negative 3. So let's simplify now. So we say 9 times 2, that's 18. And 2 5s 10. So that's 18 times 10, which is 180. This will give us 18. This will give us 10 when multiplied. So that's 2 9s 18 times 10 is 180. All right, next, let's subtract the value of this expression over here. 4 2s, that's 8. Let's write that side work. Negative 3 times negative 3 times negative 3. So we know negative times negative, that's positive. And that positive product times negative will give us negative. So we know that's going to be 8. Let's write 8 here for now. So that's 8 multiplied by negative times negative times negative, that's negative. 3 3s, that's 9. 9 3s, that's 27. So we have 180 minus the product of 8 and negative 27. So what we're going to do, we're going to say, okay, we can break this up. In fact, you know what we could have done earlier? If we wanted to, we could have, not go so fast by saying, we could have said 9 times 2, that's 18. And then we could say 2 5s, that's 10. All right, so we have this expression over here broken up in 2 parts. That's 18 times 10. And this expression over here in 2 parts as well. That's 8 multiplied by negative 27. And so we have 180 minus, and 8 times 27. What's the answer for that? So we can see 27 times 8. 8 sevens, that's 56. 8 twos, that's 16. Plus 5, that's 21. So that's 216. But mind you, this is, we can say, well, if we put back this negative or minus sign there, then we're just working out the result for this. So that will be negative 216. Okay, so this, remember, this, we're treating this as a positive 8. So we're subtracting the product of 8 and negative 27. So we're subtracting, what's the product of 8 and negative 27? That's negative 216. So we're subtracting negative 216. Hope that is clear. And then, once we have these two signs together, these two signs here next to each other, we can treat this as what? 180. Subtract negative is plus. Remember that? We subtract negative, that's positive. So that's going to be 180 plus 216. Now what you could have done from the get-go, you could have said, okay, since we're multiplying this portion here, right? You could say, well, you know what? Let's take the sign before the 8, which is, we see a minus sign before the 8, but we're going to treat it as negative 8. And we're going to say negative 8 times negative 27. It's okay to take the sign before the 8, okay? So we can say negative 8 times negative 27. That's negative times negative, that's positive. So right away, from the very get-go, we could have simply said, okay, 18 times 10, that's 180. And negative times negative, that's positive. And 8 times 27, that's 216. And we add that, we're going to get what? All right. Now I could add that in my head, but I want to show you quickly what we'll do, right? So we're going to put 180, 216. And when we add in according to the place values. So in the ones column, we have 0 plus 6, that's 6. Tens column, 8 plus 1, that's 9. hundreds column, we're going to put 1 plus 2, that's 3. Ones, tens, hundreds, and so that we have 396 as our final answer. All right, now let's look at question 2D, since we're looking at the second question. So you can check out the video for the first question. Check it out in the description. So this is really question number 2. All right, so let's look at part D. So we're saying 5 times x, 5 multiplied by x, multiplied by y squared, which is y, times y. Then we're going to have in the denominator, we have 9 multiplied by the square of z, so it's going to be z times z. Then we do our substitution as usual. So we need to look at the question, what it's saying here. So this part A, B, C, and D has to do with the original question, question 2. So for part A, B, C, and D, question 2. If you had another question number like number 3, you would not look at these values. It must be based on the question that it's part of. So A, B, and C, and D are part of this question. Okay, that's important. So notice in the homework, in the test, I should say, that persons actually utilize these values for a different question number. No, each part of the same question has to do with these. But once you go to a different question, like a different question number, part A, B, and C, and D of that other question would have nothing to do with these numbers, but whatever is given for those. Okay, so the x is 2 and the y is -3 and z is 5. So let's keep that in mind. 2, 3, 5, but -3. So let's substitute 5 multiplied by 2 for x, -3 for y. We should have another multiplied by y again, that's -3. Let's put the multiplication sign between them. I'm going to have 9 times the value of z. And the value of z is 5, so we're going to have 9 times 5 times 5. Now let's look at it. We have all multiplications, so we can put them in parts. 5 2s, that's 10. Multiply by negative times negative is positive, and 3 3s, that's 9. That's 10 times positive 9. And then we can say 9 5s, that's 45. That's 45 times 5. Let's simplify that now. A little further, simplify it further. So we have 10 times 9, that's 90. Now 45 times 5 is what? Okay, let's do that at the side. 45 times 5. 5 5, that's 25. 5 4s, 20 plus 2, 22. So that's going to be 90 over 225. Now if you look at it, you want to simplify this, it might be a little challenging. So what we could have done, could have said, since we're multiplying, since these are all factors on top, 10 times 9. So 10 is a factor, and 9 is a factor of 90. And 45 and 5, these are factors of 225. Since we have factors at the top and factors at the bottom, then we can simplify factors with factors. So we can say the numerator factor divided by the denominator factor. So we can say 5 goes into 5 once, and 5 goes into 10 twice. Then we can simplify further. We could say 9 goes into 9 once, and 9 goes into 45. 9 5 is 45, right? So it goes 5 times. So in fact, what we're left with is 2 over 5. 2 over 5. So we go straight to 2 over 5. Okay, so rather than having to deal with this big fraction here, we could just simply simplify. Okay, so let's go over that one more time quickly. Once you reach this stage where you have quantities on top multiplying and quantities below multiplying, in fact, we could even go a little earlier. Let's look at this stage up here. All right, so we could have said, okay, all right, so we have all factors on top, because we're saying quantity times another quantity times another quantity times another quantity divided by a quantity times another quantity times another quantity. So it's all multiplication. It means that these numbers at the top and bottom are all factors because they're multiplying. So we can simplify. So we can say simplify by dividing numerator with denominator. So we can say let's go. We could say 5 goes into 5 once. 5 goes into 5 once. Anything else? Yes. We could say 3 goes into 9 3 times. So that's 3 into 3 once and 3 into 9 3 times. We're left with a negative 1 here, so we want to pay close attention to that. Now look at this. We have 3 here now, because we divide 9 by 3, which was 3. So we can cancel 3 into 3 goes once, and 3 into this 3 goes once. So what we're left with is negative. This negative is still there. So negative 1 times negative 1, that's positive 1. So positive 1 times 2. In fact, we can actually put this here. Let's go. So it's going to give us, there's going to be positive 1. Negative 1 times negative 1. Negative and negative is positive. So that's 1 times 2 is 2. And 2 times 1 is still 2. And all we're left down here with is 1 times 1, which is 1, times 5 is 5. So our answer is really what? 2/5. And so that's it.